So in this video we're going to solve few more problems regarding using the Schubert equations, and they can be solved without graphs since we haven't discussed the graphs yet. So these problems are taken from the old M1 book, but I think they're quite good. So the problems, the worksheet has been given in the video description. So you should actually, using the worksheet, you should try to solve the problems first in your own and then actually have a look at the video. So the first two problems are actually very easy. That's why I'll not discuss them in the video. I'll start from problem number 3. So let me read the question first. A particle moves along a straight line ABC with constant acceleration. AB is equal to 50 centimeters and BC equals to 150 centimeters. After passing through A, the particle travels for 2 seconds before passing through B and for a further 3 seconds before passing through C. Find the acceleration of the particle and the speed with which it reaches C. Actually, this problem when I first tried, I found it a little bit tricky. I actually did it in a different way using graphs actually. So that actually made the problem a bit more difficult. But I'll show you that method also later after I discuss graphs. So, but actually, if you use this formula, S equal to Vt minus half At square, this is a formula actually in my life I've used not that much. The other formulas actually are more useful and more commonly used even in the exam questions. But this is a question where if I use this formula, the sum becomes much easier. So let's look at visualize the problem. So you have ABC. Particles moves from A to B, then to C. Okay. So this AB distance is, this is 50 centimeters, and BC, this is 150 centimeters. So after passing through A, the particle travels for 2 seconds before passing through B. So the time to come from here to here, from A to B, that is actually 2 seconds. Then from B to C, it takes 3 seconds. Now and we are assuming we have the constant acceleration here. So we have to find the acceleration of the particle and the speed with which it reaches C. So I've said before we are going to use this formula. This formula, S equal to Vt minus half At square. So now let's say I take, so V is the final velocity. So I have to take the motion in such a way so that the final velocity is the motion at C. For example, if I take the motion from A to B only, then the final velocity is the velocity with which the particle reaches B. But we actually want to find the speed with which it reaches C. So we'll take the motion in such a way so that the final velocity is the velocity at C. So let me first take the motion from A to C. So what is the value of S? S is going to be 200. Value of V, that is the velocity at C, that is what we have to find. The time taken to go from A to C, that will be 2 plus 3, 5. So 5 into V minus half, the acceleration is A, and T square, so it is going to be 5 square. Okay, that is the motion from A to C. Now I can take the motion from A to B, but if I take the motion from A to B, the V is going to be this V, and that V is not going to be the same. In that case, if I take the motion from A to B, the final velocity is the motion velocity at B. But let's say I consider the motion from B to C. In that case, my S is going to be 150, and the time will be 3 seconds, so it will be 3V minus half A T square. T square is actually will be 3 square. So actually what do you have over here? You have two simultaneous equations, and there are two variables. One is V, the velocity at C, and also the acceleration of the particle. So if you solve them, you get this answer. 65, take care of the units, 65 centimeter per second, which is actually equal to what? 0.65 meters per second. Also, the acceleration, the value of the acceleration you're going to get as 10 centimeter per second, which is the same as 0.1 meters per second. Okay. So basically, the key to this problem is to use this formula. Then your life will be much easier. And I'm actually assuming that you know how to solve the simultaneous equation, which is, but you have to show, not a lot of steps, but actually you have to show some steps how actually you solve the simultaneous linear equation. Yes, now let's look at the next problem. Two runners, Aisha and Fatima, are completing, this will be question number 4 in the worksheet. So two runners, Aisha and Fatima, are completing a long distance race. They are both running at 5 meters per second with Aisha 10 meters behind Fatima. When Fatima is 50 meters from the finish line, Aisha accelerates but Fatima doesn't. What is the least acceleration Aisha must produce to overtake Fatima? This is the first part of the question. The second part actually is saying, if instead Fatima accelerates at 0.1 meters per second square up to the finish line, what is the least acceleration Aisha must produce so that Aisha just overtakes Fatima, or at least Aisha. Okay. First let's look at the first part of the question. Aisha is 10 meters behind Fatima. So here you have Fatima, here you have Aisha. This distance is 10 meters. This is the end, that's the end of the race. And so when Fatima is 50 meters from the finish line, so let's say, so this distance is 50 meters. So now Aisha accelerates but Fatima doesn't. And we already know their velocity at this point. For Fatima and Aisha, for both of them it is 5 meters per second, but from this point onwards Aisha actually accelerates but Fatima goes at the same speed. So what is the least acceleration Aisha must produce to overtake Fatima? So the least acceleration will be like when Fatima reaches over here. Okay, so at the same time the acceleration must be such that at the same time Aisha also reaches over here. Technically it has to be just slightly greater than that so that Aisha can overtake Fatima. Okay, so basically in the time that Fatima comes from here to here, Aisha has to come also from here to here. Okay. So first let's find the time taken by Fatima to finish the race. The time taken for Fatima to finish. So I'm just writing time. It will be what? Distance by time. So distance is 50 meters divided by 5, the velocity. So it will be 10 seconds. This is the time taken for Fatima to come from this point to this point, to the end. Now the acceleration of Aisha has to be minimum such that in the same time it travels this distance. So what is this distance actually? This will be 60 meters. So this is 50, this is 10, so this distance is 60 meters. So let's say I use the formula s equal to ut plus half at square. So the distance traveled by Aisha is going to be 60 and initial velocity is 5 u, and what is the value of time? The time is 10 ut plus half a, we don't know the value of a, t square, so t will be 10 square. Okay, and if you solve this you get the value of a as 0.2. Okay, so the acceleration, the minimum acceleration for Aisha will be 0.2 meters per second square. So first we found the time for Fatima to travel the 50 meters, that is 50 by 5, 10 seconds. So in the same time Aisha must cover 60 meters so that she can just overtake, or she is about to overtake Fatima. So Aisha has to travel 60 meters in the same time. So I am using this formula, s equal to ut plus half at square. Okay, so the only unknown is the acceleration, and you find it. Now let's move on to the second part of this question. So now they're saying that if instead Fatima accelerates at 0.1 meters per second square. So from here to here now, Fatima is not traveling at a constant speed, rather she is accelerating. 0.0 meters per second square, the acceleration is given up to the finish line. So what is the least acceleration Aisha must produce? So what is the least acceleration now Aisha must produce? So since Fatima is accelerating, now Aisha, like you can actually say that the acceleration will be greater than 0.2 meters per second square. But what will be that acceleration, that we have to find out. So let me first rub this. So let's proceed in the same way. So I have to find the time it takes Fatima to go from here to the finish line. So the time, so again let me use S equal to ut plus half it square. So S will be 50 ut. So u is 5 like before. 5 into t, because I don't know the time now Fatima takes to go from here to here. Ut plus half a is 0.1 t square. So this is actually, you get a quadratic equation. You have to take 50 to this side, then you can just use the quadratic formula to solve this. You actually have to show this step, okay, and show how you are inserting the values into the quadratic formula. So I am not showing that. So there are two values of t that you will find. One will be 9.1608. The other will be minus 109.16. So this is a negative value, clearly not applicable for time. So this is the time that Fatima takes to travel this 50 meters right now. Now again we'll use the formula S equal to ut plus half it square, but for Aisha. So Aisha has to travel 60 meters and ut plus u is 5. You know the time, 9.1608 plus half a, 9.1608 whole square. So you find the value of a. The value of a will get us 0.34. So the acceleration will be, for Aisha, will be 0.34 meters per second square. Okay. And you actually observe that this acceleration is actually greater than 2, and that is, you can actually get that directly from common sense.